Okay, hello and welcome to another Roboguide demo. In this video I'm going to demonstrate Lab21, which is the one where you create a group of outputs and have them count up as a binary number. There's also another part where you set a couple of outputs up as complementary so that they work opposite each other. So let's start first with the complementary output. So in the lab handout for Lab21, the first thing you need to do is set up a couple of outputs as complementary. And on Blackboard, I mentioned you should use outputs 3 and 4 for complementary outputs. And then when we get to the group, we'll use outputs 5 through 8 for the group. Okay, so to get to the outputs, you go to Menu, I/O, Digital. And so if it comes up, if it says in digital inputs, you have to click this in/out, and that brings you to output. So you can switch back and forth between the inputs and the outputs. So when you're doing complementary outputs, you can either complement 1 and 2, or 3 and 4, or 5 and 6, 7 and 8. So you'll see you can't group 2 and 3 together. Make those complementary. So to get 3 and 4 as complementary, we just click on the output and go over to Detail. So you hit this arrow, click Detail, and down here where it says complementary, we just cursor down to that. And actually, okay, so I guess it was already true, but so I'll just make that true. If it says false, just make it true. So I guess I had it left over from a previous lab. And then it says here, power off, then on to enable changes. So what that means is if it were the real robot, we would switch the power off and on. And to do that in Roboguide, you can either save and reopen the file, but it's actually quicker to go to the robot menu and do a restart controller, do a cold start. Okay, that'll take it just a moment to restart. Okay, so now we're back. So now if we go to the menu and to the I/O, go to digital outputs, and we can take any output, turn it on, turn it off, output 2 on, off. When we go ahead and turn 3 on and off, turn it on first. Now when we turn it off, notice that 4 automatically turns on. We turn it back on, 4 turns off. And if we go to 4, same thing. Turn it on, then 3 always stays the opposite. This is a common configuration when you're working with pneumatic valves, because very often pneumatic valves have 2 outputs, one to switch the valve to one position and one to go to the other position. And so you'll very often see complementary outputs used to control the 2 valves. Okay, that's the first part. So the next part of the program, we're going to eventually run this program down here where we're going to take a group of 4 outputs and group them together, and they're going to act as a single binary number. So we have a few things. This is the program we're going to write, and I'll talk through it first, and then we'll talk about some of the things we have to do to prepare for it. So what the program is going to do is we designate this first output, output 1, as our ready indicator. So the first thing the program does is turn that on, so we'll see that turn on, go green. And then there's a wait command, and rather than waiting for a specified amount of time, this one waits for an event, and the event is for digital input to turn on. So we're actually going to do that. We're going to turn that input on. So until we do that, it's just going to sit there on line 2. Once we turn it on, the ready light is then turned off with this command. The group output is set to a 0, and then we get into the loop part. So there's a label, that's the beginning of the loop. We're going to take that group output and assign it to the group that we made of the outputs. So those 4 outputs should then become like a binary number. So first it's going to be 0, so they'll be all off. Then we increment the group output by 1, wait for a second, And then we check to see if the group output has gone past the max number. So we're going to, in this second register, register 2, we're going to store the number 16. So it's going to keep checking to see if it's reached the number 16. As long as it's less than 16, it's going to jump back to the label and then reassign the group to the register to the group. Remember, that register keeps going up by 1. So the next time it goes through, it's going to be 1 more. So we're going to see that group of outputs start counting in binary sequentially, 1, 2, 3, and so on. So once the group output does hit, once it increments and it becomes 16, the number 16 is not less than 16, so that it stops jumping and it comes down here and sets the whole group back to 0. Okay, so that's the basic program. So what we have to do is we have to designate a couple of outputs, an output and an input, and then a couple of registers. You can see these labels. So we're going to just go through and label them right at this point. We also need to create this group output. So why don't we do that first? Let's create the group output first. All right, so to group outputs, before you can actually go into the group, you have to get some information about the outputs that you're trying to group. Now, you may remember from the presentation on inputs and outputs that the inputs and outputs are configured in terms of rack, slot, and start point values. So that's kind of indicates the actual physical location of the output in terms of a rack, a slot on a rack, and an actual screw terminal output. So to get that information, I have to go to the config menu. The config option here. And so right here it says outputs 1 through 8 are rack 0, slot 1, start point 21. That means output 1 starts at point 21. So if we want to get to output 5, it's just sequential. 21, 22, 23, 24, and 25 would be the start point for output 5. So that would be a good thing to write down unless you can memorize it. Rack 0, slot 1, start point 25. And now we're ready to go over to the group and configure the group. So you go to I/O, go to group, and we'll just use group 1. And we're going to go to config. So the rack was 0, slot was 1, and the start point is 25. Now we also have to tell it how many points there are in the group. We're going to group together 4 outputs, so that will be the number of points. Okay, so once we've done that, that's another thing that requires us to restart the robot in order for the group to actually go into effect. So we go back over here to robot menu, restart controller, cold start, and just wait a moment for that to cold start. So while that's doing the cold start, we'll go back over here. Then we're going to name some of these outputs and inputs. We're going to name output 1 ready. We're going to name input 1 start program, and then a couple of registers, register 1 and register 2 for group output. Okay, so we got our teach pendant back, and if we go to data, register 1, so to label a register, you just hit the enter key and then click options keyboard. So this one is going to be called I can't remember. What we're supposed to call this? Okay, group output. Okay, and then the next one, register 2, that's going to be called max number. So that's going to be where we will store the max count for the program. And I'm going to start off with a max count of 16. So it should count all the way through from 0 to 15. When it hits 16, it'll stop. Okay, and then we're going to go to the I/O menu, digital, and we're going to label digital output 1. So to do that, to label an output, you have to go down here, do a forward arrow, click on detail, and then where it says comment, hit enter, and then you can bring up the keyboard. So this one is going to be called ready. It's going to be the ready indicator. Okay, and then we want to go over to the inputs now, and we're going to label input 1. Again, we have to click this forward arrow, go to detail, hit enter, options, keyboard, and this is going to be called start program. Okay, so there's our output and input. So now we're ready to write the program. We're going to basically write this program, and then I'll demonstrate how to run it and how to test it.